So the main question we want to ask ourselves in this lesson is, can we manipulate inequalities with addition and subtraction like we manipulate equations? Let's take a look at the two examples below and add 4 to them. So let's take a look at this example. X minus 8 is less than 12. So what we can do to get rid of the minus 8 is, just like an equation, we're going to do its opposite. Add 8, and what I do to one side, I do to the other. Minus 8 and plus 8 cancel out. We just get X. Less than symbol drops down, and 12 plus 8 is 20. So just like with equations, with addition and subtraction, we are allowed to just do opposites, just like we do in the past chapter, and come up with an answer of X is less than 20. Now, if we want to graph this, just like we discussed in the last unit, we want to graph all numbers that are less than 20, but it doesn't start at 20. I mean, the first number here we'd want to graph would be something like 19.9999998. So to show that, we do an open dot at 20 to say start here at 20, but don't include 20 itself, just everything below 20. So an arrow to the left. Alright, so let's try another problem. In this case, we've got 7 is less than or equal to n plus 2. So again, with addition and subtraction, we can treat it just like an equation. We're trying to get rid of the plus 2, so we're going to subtract 2 from this side, and what I do to one side of the inequality, I do to the other. Now, over here on the left, we get 7 minus 2, which is easy, that's 5. Less than or equal to symbol drops down. And then over here, n, and then the plus 2 and minus 2 cancel each other out because they're opposites. Now, in this case, we get something a little different, which normally with equations isn't a big deal, but with inequalities, it gets a little tricky. The way this reads is 5 is less than or equal to n, which, at least in my mind, is a little bit difficult to graph. I get a little confused about how to read that. 5 is less than or equal to all my numbers n. So usually what I do in this case is I flip things around. I reverse my inequalities, which we've done with equations, where we put the variable on the left and the number on the right. But in this case, because direction is important with an inequality, this less than symbol needs to flip around into a greater than symbol, okay, which is now easier to read. But you have to be careful that when you flip this inequality around, that you flip the inequality symbol so it basically points in the opposite direction. So now I can read this, n is greater than or equal to 5, which I can now make more sense of. So when I go to my graph, to actually graph it on a number line, I can say n is greater than 5, which is going to be all the numbers over here, or equal to 5. So that means 5 is equal, or n is equal to 5, means a closed dot, and then anything greater than that would be an arrow to the right.